Welcome to our next unit. We are going to be looking at RF2 that talks about quadratic equations. We talked about functions, right? We analyzed the whole graph. Now we're going to talk about when these are actually equal to a value. When we talk about equations, we're usually looking for solutions, which means a specific x value or any value that satisfies our equation, right? So if you said 2x equals 6, we know that the solution to that x has to be 3 because 2 times 3 gives us 6. We're going to be looking at how we can solve quadratics, so where we have x squareds showing up, in a few different methods. So we're going to solve by graphing, we're going to solve by factoring, and we're going to use the quadratic formula. So those are going to be our 3 main topics for this unit. First off, we're going to look at graphical solutions of quadratic equations just to get an idea of what these solutions are. So we have a few different terms here. The solutions of an equation, when it is equal to 0, are called the roots. Right? So you may have seen that term before on your graphing calculator in the notes. So roots essentially are the term for solutions when we're talking about quadratic functions. Right? Because a quadratic is a squared equation, the solutions are roots because we're eventually square rooting or using the idea of a square root. The x values, where the function is 0, are called zeros. So that's actually the same value as the roots. They're kind of interchangeable terms. And then lastly, where are these things found, right? What are these solutions? Well, they're actually the x points of our x-intercepts, right? Those points where our graph crosses the x-axis. That's where we're going to find our solutions graphically. In each of these equations, we're going to be looking at some quadratic function, right? 2x squared plus 2x minus 12 is quadratic because we see that x squared. Normally, when we analyze the functions, we're looking at when is this thing equal to y, right? Just a generic function with an x value relating to y values. We're going to be specific when we're solving. We're saying, when is this thing equal to 0? When is essentially our y value 0? And that's what the x-axis is, right? When our y value is 0, that means we haven't gone up or down at all. We're somewhere along this axis here. So when we solve an equation, we're essentially saying, where are our x-intercepts? Right, so 2, 0, we have one x-intercept here. The solution is just the x value, it's the 0. Right, so it's going to be this value of 2. So x equals 2, that's how I would state my first solution. I have another x-intercept because, like we know, these things can intersect the x-axis at most 2 times. And I have another root, or 0, at -3, so another solution at -3. So positive 2 and -3 are my solutions. Well, what does that mean? What does it mean to be a solution? Yes, it's an x-intercept, but why does that solve this equation? Well, if I take my equation, 2x squared plus 2x minus 12, and say that it should be equal to 0, right? An equation is saying the left side and the right side are the same. They're equivalent. They're equal, right? So how can I make this left side equal to 0? Well, theoretically, my solutions do that for me. So my solutions are x values. So in place of x, I'm going to start with the 2. I'm going to plug in 2 for each of my x's. I'm going to start to simplify the left side here. I want to make sure that these two sides really are equivalent. So I want to see, is this left side actually 0 once I get through all the math? So I follow my order of operations. I follow BEDMAS. I'm squaring the 2 first, right? 2 squared here. Exponents come first before any of my other operations. 2 squared is 4. Plus 2 times 2 minus 12 equals 0. Now I can do multiplication, right? Now I can do 2 times 4. And while I'm at it, I'll do 2 times 2. So I have 8 plus 4 minus 12 equals 0. And 8 plus 4 is 12, minus 12. So I get something that looks here like 0 equals 0. We sometimes like to say left side equals right side, right? The left side of the equation is actually just a really fancy way of writing 0 with this specific x value. So that was the case where x was positive 2. Notice it works out. It gives us something that makes sense, right? It gives us a solution. If I was to do the same thing with negative 3, because I do have two solutions. So what that means is that both of these values should, what we say is, satisfy the equation. They give us something where left side equals right side. So I would have 2 times negative 3 squared plus 2 times negative 3 minus 12 equals 0. I'm going to square first 2, right? Being careful here, negative 3 squared is positive 9 because it's negative 3 times negative 3. Plus 2 times negative 3 minus 12. 2 times 9 is 18. 2 times negative 3 is negative 6. Whoops. 18 minus 6 minus 12 is 0. And when I ask myself, what is 18 minus 6 minus 12? Well, again, it gives us 0. And left side equals right side. That means that x being negative 3 is also a solution that satisfies this equation. These are the only two values that are going to do this. If I was to plug in like a 0, well, 2 times 0 is 0. Plus another 2 times 0 is 0, but then I get a minus 12. So it doesn't equal to 0 on the left side of the equation, right? And that's why we see those points in other locations on the graph. If I was to choose an x value of positive 4, or sorry, let's go positive 3, right? Here it is on the graph. Notice that it doesn't have a y value of 0. So it's not going to give us a proper solution. That's why we're looking for those x-intercepts. Let's try another one. What are the roots of negative x squared plus 8x minus 16 equals 0? Well, let's look at a graph of this. We don't have the graph this time, so we'll do our best to graph it. First, we'll pick out what A, B, and C are, reminding ourselves that these are all in standard form, which looks like, ax squared plus bx plus c, and in this case equals 0. Right, again, equations, we're going to see that equals 0. Functions, we see that equals y. Equations, we're looking for those specific points where it is equal to 0. Functions are just the graph as a whole, those trends and characteristics. Here, a is negative 1, b is positive 8, and c is negative 16. Let's see what this graph looks like. So we'll pull up a calculator. Here we go. We can go to our graphing menu. If there's anything here, we'll get rid of it. So we had negative x squared, making sure you're hitting that negative sign, not the subtraction sign, plus 8x. And it was minus 16. Now we're using the subtraction sign because there's something to take it away from. I'm going to graph it. If your window settings are altered, remember you can always go to zoom. And then number 6 for zoom standard. So there we see our graph. We ask ourselves, what are we looking for? Well, we're looking for solutions. Remember that those solutions actually showed up at x-intercepts. So I can find an x-intercept by choosing this value option, right? If I pick some point to the left of my x-intercept, some point to the right of my x-intercept, right? The guess, we can move if we want. Really, we're looking for this point here where it looks like our graph hits that x-axis. And our calculator tells us it's at 4, 0. So let's plot that point on our graph. 4, 0. This thing opens downward because of that negative a value. And it looks like we have a y-intercept of negative 16 coming from that c value. So I could plot some points, right? I could look at my table. Second graph gives me the table, just so I can plot some nicer points. So 3, we're at -1. 2, we're at -4. Right, just so we can get a good representation of this graph. So what are our solutions? Well, our solutions are those x values of the x-intercepts. And our x-intercept was at 4, 0. So x equals 4 is our solution. This time we only have one solution because there is only one x-intercept. Right? Remember, there was multiple possibilities. We could have one x-intercept, we could have two x-intercepts, or we could have 0 x-intercepts. And that means that we would have no solution. So there are 3 more examples here. I want you to give these examples a try. Graph using whatever technology you have. Make sure you're drawing a nice sketch of your graph. You're plotting the points, right? You're using your table to create a nice, accurate graph. And then you're determining your x-intercepts to then tell me the solutions, right? Make sure you're expressing your solutions as just an x value. The x-intercept, the point, the coordinate, helps us, but it's not actually the solution if we include it as an xy point. So give these 3 examples a try, pause this video for a minute, and we'll come back to this in a minute. All right, let's look at some of these solutions. So on our first one, x squared plus 2x minus 15. All right, I plug this into some sort of technology, my graphing calculator, Desmos, right, some sort of technology. I can see here that my x-intercepts are at -5 and +3. Right, so those are my solutions. X is 3, x is -5. Both of these are solutions. Everything stays the same, we keep the sign, we just express it as a solution, right, as 0, instead of as the whole x-intercept, as the point. Example 4 gets a little bit tricky because we need this to be in standard form. So notice what I've done here. I have added 2 to both sides because I want to figure out when this thing is equal to 0, right? That's how we know that our solutions are x-intercepts, is only when we're looking at the case where it's a quadratic equal to 0. That's also going to, if we notice, change our c value. It's actually a +2. When I graph this, it actually gives me no x-intercepts. That means that I have no solutions. There is nothing that makes this equation up here in black true. Notice, because everything is positive, and we're always going to be squaring x or adding x, if x is a negative number, we're squaring it. It's going to become positive. If x is a positive number, it's going to stay positive. There's not enough here to end up equaling 0. Right, that's being subtracted or that's going to be negative to balance these things out. And then looking at the last one, 3x squared minus 6x minus 7, right? This time my x-intercepts are not nice numbers, right? They don't fall on nice integer values. We have a 2.83 and a -0.83. All right, and I'm just finding these from my graphing calculator. I'm going to go second trace. I'm going to choose this 0 option. I pick some point to the left of one of my x-intercepts. Then I pick another point somewhere to the right so that my x-intercept is between those 2 lines. We do one x-intercept at a time. And I get that value, -0.82574, whatever, round usually to the nearest hundredth. Right, just so we have a couple decimal places there. Right, so we still have solutions. Even though they're not nice integer values, we still have solutions. And so we need to make sure if we see x-intercepts, we find out the exact coordinate point of those so that we can pull out the exact specific x value. And so that's all for solving quadratics graphically. In the next video, we're going to look at how we can solve them in a few algebraic methods.